Hello, welcome to the third lesson in Spiral 4. And we're changing gears in the spiral. We're now moving back into some measurements. We're looking at volume of cones and pyramids today. So basically, I just want you to be able to determine the volume of pyramids and cones. So now we're talking about the relationship. So what's the relationship? We learned about volume of a cylinder in Spiral 3. What's our relationship with the cone? If you draw two kind of ellipses and connect it, you end up with a cylinder. If we were to draw a cone inside this cylinder, notch up in the middle, okay, so if we put our cone inside the cylinder, has the same radius and the same height, so this would be the radius as well. We know that the volume of a cylinder is pi r squared h. So we talked about it's the area of the surface. So it'd be the area of the base multiplied by the height. That's your volume formula for any shape. The cone itself, again, if this was in a regular class with me, we would do a quick demonstration. And what we would find is that if we filled this cup up, all right, so if I took that cylinder and the cone, and I poured water into the cylinder, we would find that it takes 3 of these to fill one cylinder. All right, so that's why the formula for the volume of a cone is pi r squared h divided by 3. It's 1/3 of the cylinder. All right. Similarly, if I was to draw a cube, so let's see how this goes. So I'm going to draw 2 squares that I can connect just like that. Here's my cube. If I was to draw a square-based pyramid, so it shares the same base, and we put the pyramid inside, we would find that it's the exact same relationship. So the volume of the cube is length, width, and height. The volume of that pyramid is length, width, and height divided by 3. And then if I extend that formula a little bit, all right, well, the base is the same. So it'd be length times length, or base squared. So I think that is the formula that they use on the formula sheet. So there's your relationship. In both cases, a cone is 1/3 of a cylinder. A pyramid is 1/3 of a cube. So that's where that divide by 3 comes into play for both of these formulas. And like I said, if it was a regular classroom, I would do a quick demonstration to prove it. You can always ask your teacher for the manipulatives and to try it yourself so you can see it firsthand. Just take it up to the fountain and test that theory itself. All right, so all we got to do is do some calculations now. So find the volume of the given pyramid. So this one, the challenge here is this is not a square-based pyramid. So volume equals, so we're going to have to use that formula I had originally, length, width, and height divided by 3, because really, if I can draw it properly, this, okay, is just 1/3 of a box. All right, so to find the volume of the box, you would say, well, the length was 12 times 5, and the height was 8. And we only want the pyramid that fits inside it, so I just need 1/3 of the box's volume. All right, so again, my diagram, not great, but it gives you a general idea. Divide that by 3, so we end up with 160 cubic yards, or yards cubed. All right. And for the volume of the cone, okay, again, this cone would fit inside that cylinder. So what's the volume of a cone, or the volume of a cylinder is pi r squared h. We just want the cone, so we're going to divide it into 3 parts. So 3.14. Now just be careful, make sure the radius is given. And if you note, this is not a radius. You know this because the red line goes across the entire base. So that is actually a diameter. So the diameter is 22, which means the radius would be 11. So 11 squared times 22 divided by 3. So when you do that calculation, times 11 squared times 22 divided by 3, we end up with 2,786.2, and this one is cubic feet. All right. The next example is a triangular-based pyramid. So we know that volume of any shape is the area multiplied by height. So we just need to find the area of this triangle. We know the area of a triangle is length times width divided by 2 multiplied by height. So here we would have, this is where you got to be careful. Always look for the right angle. That's where I would start. So this would be your height. That is your base. So we'd have 8 times 6 divided by 2. And the height is indicated by that right angle showing the altitude. So multiply by 7. So 8 times 6 times 7, divide that by 2. And we get 168 cubic inches, or inches cubed. And then, on the example below, we have a conveyor belt dropping sand. And it spreads out, making a giant inverted cone. So if this is my conveyor, and sand's dropping, here is the cone. It has a 33-foot diameter. So again, 33 feet. So if my diameter is 33 feet, my radius will be half of that. So you make sure I'm going to take care of it right now so I don't forget. It's filled to a height of 10 feet. So it's given us the height of the cone, 10 feet. And a truck can hold 135 cubic feet. How many trips? So this is a two-part question, because first of all, we got to figure out how much sand is in the pile. So that's our first step. How much sand is there? So it's a volume of cone, pi r squared h divided by 3, 3.14. We figured out the radius, 16.5. Multiply that by the height, which is 10. So 3.14 times the 16.5 times 10, divide that by 3. So there is 172.7 cubic feet in that pile. Step 2 is how many trucks. So we got to divide that up into truckloads. So 172.7. Each truck holds 135. So I think you can see where this is going. So it's going to be 1.3 truckloads, but of course you can't have that. So therefore, it will take 2 trucks or 2 truckloads to move that much sand. All right. And then on to our final question here. A cone has a base diameter of 12 meters. So again, they are giving us the diameter. You got to be careful with that. So the diameter is 12 meters. We just want the radius, which will be 6 meters. And a slant height. So there's a new term here, slant height. Slant height is the length along the edge of the cone. So that is 5 meters. We want to find the volume. So this is actually going to be a bit trickier of a question. We need to find height. So what shape, when I draw that height in there, we end up with a right angle triangle. So if we explode that out or pull that out, we need to solve for height knowing this information. So you have 2 options here. You can use your Pythagorean theorem, or you can go with the areas method. All right, and this is an interesting question because this won't work. A hypotenuse is not the longest side. if you'll notice, take a look here, this is a 5 and this is a 6, so this doesn't work. So we type this question up. Not correct, so let's change the slant height to 15. Make this work. There we go. All right, so area using Pythagorean theorem, we're looking for a missing side. So it would be b squared equals c squared minus a squared. So b squared equals the hypotenuse squared minus the shorter side. Remember, you have to do the squaring first. So 225 minus the 36. So b squared is equal to, that's 189. Take the square root of both sides, and you get 13.75 meters for the missing side. For the people who do the area method is if that creates a square that's 15 on that side, 15 squared is 225. So I put areas in circles. This area is 36. We know that these two areas add up to the big area. So 225 minus the 36, the area on this side has to be a 189. And if you want to get back into length, you have to take the square root, and you end up with the 13.75. Now we can go ahead and we can calculate the volume here. Volume equals pi r squared h over 3, 3.14. The radius is 6 squared, and the height is 13.75. So this is the extension to what we did in spiral 2 and 3. You have that extra step where you got to deal with, or be able to deal with, slant lengths. So we will be using Pythagorean theorem again. And that's why we covered it earlier on. So that's 518.1 cubic meters. All right, if you have any questions for any of the steps here, please make sure you stop the video and ask the teacher, but good luck with the homework for this section, and like I said, if you have any problems with it, make sure you ask for help. See you in the next video.